What is up, people, and welcome to another video on the Kubernetes Lightning series, a series where we learn about Kubernetes from scratch. In previous videos, what we have done is installed Docker, learn about containers. We've got a container running locally. We built our first container using a Docker file. Then we took the second step by creating a small, lightweight Kubernetes cluster that we can run locally. This will allow us to learn everything there is to know about Kubernetes. In order to talk to Kubernetes, we learned about a tool called kubectl, which is a command line tool that allows us to talk to Kubernetes, deploy things, troubleshoot, monitor, and simply manage a Kubernetes cluster. Now, when talking to Kubernetes, we talk to Kubernetes using the API, and we do so using kubectl. Kubectl sends command to the Kubernetes API and will do things for us. Either we can get resources to troubleshoot what's going on and manage our cluster, or we can apply resources. We tell Kubernetes what we want it to deploy, and it manages the desired state. And we define the desired state using a template. We tell Kubernetes exactly what we want to deploy, how many servers we want to run. Maybe you want to deploy a website with a web server and you want to load balance to 2 instances. Maybe you want a database server. You basically craft up a template and use kubectl to deploy it. We briefly used kubectl in the previous video, and looking at those templates are written in the form of YAML. So when you're new to Kubernetes, it's very important to learn about YAML. In this video, we'll do just that. We'll take a look at what YAML is, the syntax and the structure to write an effective YAML file, and to understand the syntax. That way, when you're dealing with Kubernetes, the YAML does not get into the way. So without further ado, let's go. Now, if you're new to this channel, everything I do on this channel is always on GitHub. We have a GitHub repo where you can find all the source material. The GitHub repo link is listed down below in the description. And if you open up that GitHub repo, you'll find the Docker Development YouTube series. That is the GitHub repo, and in there is a Kubernetes folder. If you expand that and you scroll down, you will find a deployments folder as well with a deployment.yaml. And this is what a Kubernetes deployment looks like. Now, if you're new to Kubernetes, I wouldn't be overwhelmed too much about the content of this file, because in this video, we'll be purely using this as a reference. This type of file is what's called a YAML file. So if you look closely at the file name, it has a .yaml extension. Now, YAML stands for YAML Ain't Markup Language. And throughout this video, we'll take a look at the syntax and the structure of YAML and what it all means. So if you're interested in the source code, please check out the link down below to the source code if you want to follow along. Now, before we take a look at YAML, it is important to have a little bit of an understanding about the background of YAML, where it all comes from. Generally, when we run command line tools and we talk to an API server, we pass data back and forth. This is like basically called client to server communication. And in software engineering, a lot of services and web services talk to each other in a specific format when it passes data back and forth. So if you're on a website and you're filling out the website, if you open up the developers tools by pressing the F12 key and you enable network traffic, you can actually see network traffic between your browser and the web server, wherever those web servers are running. And sometimes the browser makes API calls to back-end web services as well. And generally this communication is done in JSON format. There are other formats as well, but JSON is a very popular format for constructing data objects. If you've worked on some legacy and older systems, you may also found there's format like XML. All of these types of format basically just represent a data structure. So when we run commands like kubectl get pods, or we say kubectl create or kubectl apply, the kubectl tool basically just transforms the input into a JSON object and then sends it as an API request to the Kubernetes API server. And generally under the hood, all of this data structure format is done in JSON. Even when we work in YAML, when we write out our template in a YAML format, kubectl converts this YAML into JSON and then sends it across the network. JSON is just a more popular data structure for client-server and API to API communication. So generally between systems, JSON is used. YAML is basically just used because it's very readable for humans. So generally XML, JSON, and YAML and all of these types of formats can be used to define data structures. So if we take a look at this W3 Schools website, here's an example of what a CD catalog means and what it looks like. So the entire outer structure holds a specific object. In this case, it's called a catalog, and a catalog contains multiple CDs. There's an opening node for a CD, and then the contents of that CD lives inside here, and then there's a closing notation. So when working with like XML, you have these open and closing tags. So you have to defining a tag like this, and then you put the contents of the object, and then you have to close it. So it has this specific type of format to build up an object. So in this case, we have a CD. A CD has a title, it has an artist, it has a country where the CD was produced, company, a price, and a year. So basically, objects just have properties on them, and we can describe and use XML to describe any type of object. But this is just a very, very simple XML object. It becomes quite difficult to read XML when it gets more complicated. And XML is quite old and basically just designed for server-to-server communication and designed for systems to use. It's not really designed for humans to use. It's very easy for a human to make a mistake in this file by simply missing out a bracket or a forward slash or something and then breaking the file completely. And then over the years, a new structure came out which is called JSON. And one of the benefits is that JSON does not use tags. So we don't need these opening and closing tags all over the place to describe an object. And this means it also makes it more compact because we don't have the tags. Our data is more compact, using less space. So our network traffic bandwidth is actually going to be smaller if we use JSON. And the other benefit, it is easier for humans to read. So JSON represents the same data, but just in a smaller file size, and it's faster for data transfer. So it's the most popular communication form today. And if you take a look at JSON, it's basically objects that are just formed by opening and closing brackets. So for example, this is a glossary object, and inside the glossary object is a title, which is a text field, and then it's got nested objects inside there with properties on them. So there are no open closing tags, which makes this packet a lot more compact and smaller, easier to transfer, and quite easy to read as well. So JSON is the most popular one also because it's faster for systems to use. So when a system takes this file, it can easily transform this into objects in memory and then process that object and do work with it. So JSON is still by far the most popular data structure for system-to-system communications and for systems in general. And Kubernetes uses mostly JSON under the hood. Now, although JSON has better performance and is more popular than YAML, and although it is still much easier to read, it is still easy for users to make mistakes with JSON files. Now, the mistakes don't go away. Even in YAML, there's still a lot of room for error, but YAML is just a lot easier to look at and more visually appealing to humans than JSON is. But it's important to know, even though we'll be writing YAML, as soon as we run a kubectl command, kubectl will take that YAML and convert to JSON, because kubectl will transform that object, validate it, it'll process that YAML as JSON as an object, and then it will likely use JSON to talk to the Kubernetes API server. It's also important to know that there are smaller formats that are even smaller than JSON. Those are technologies, for example, gRPC, which is a lot smaller than JSON. It gets rid of a lot of the quotations and brackets and becomes a sort of compact version of JSON. When looking at this JSON object, you can see it's much easier to read and understand than the XML equivalent. So just to show you some example, I can go ahead and copy this JSON, and in VS Code I can go ahead and paste it. I can right click and say format document. So now VS Code allows us to see and visualize this JSON object. Now if I've taken this JSON and I used something like GitHub Copilot and I just convert this JSON quickly to YAML, Look what that looks like. This is much easier to read. So here we have a glossary object. It has a title. It has another object called glossDiv. Inside there it has a title. It's got a whole bunch of nested objects basically with just fields on them, and down here it has an array of a list of items. So you can already see that this looks a lot easier on the eye and easier for humans to deal with than this JSON counterpart. And it's also good to know that YAML is just a superset of JSON. So most YAML interpreters can actually understand JSON as well. And those are like the libraries that kubectl uses under the hood when it talks to YAML files. It reads those YAML files and can convert them to JSON easily, and vice versa. Now note that I will be referencing from time to time this Kubernetes deployment file, and in a future video we'll take a look at pods and deployments. So don't worry about the content of the file, only focus on the structure, because that's the most important part. So in our Docker Development YouTube series we have the Kubernetes folder, and inside there we have the deployments folder and the deployment YAML. So just make sure you have this open if you want to follow along and refer to the same document. The first thing to know about YAML is if you look at this document right at the top, there's 3 dashes. This basically allows us to define multiple documents inside of one document file. So inside this deployment YAML, I can actually create multiple YAML files or multiple YAML objects. So for example, I can take this portion of the object. Let's create a new file. I can say dash 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 to start a YAML object, then paste my YAML object. Then I can say dash 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 and I can start a new object. So I can maybe create a Kubernetes service. So there we go. Now I have a Kubernetes service, and I can close the document by putting again dash dash dash. So I have a Kubernetes object here, and I have another Kubernetes object here. So the dash character simply allows us to tell YAML that we want multiple YAML objects within this file. So just remember, you have to state dash 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 to start and dash 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 to end. So you have to tell YAML where you want to end. You can't just start with dash 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 and then have nothing after that. So when YAML parsers generally read this document, it will know that there are 2 separate objects in this file. Now YAML objects and YAML files basically made up of key value pair. It's basically a key value pair type of document structure, and key value pairs is a common term used in DevOps. It's used to define data structures. A lot of databases are designed to store data in key value pair format as well. And then you have SQL technology, which has like tabular format of data. Key value pair is very popular because it's very small, compact, and super fast to get data back and forth from databases. That is why you'll find storages like Redis using key value pairs. So if we take a look at this YAML, basically what we see in blue is all just technically keys, and the green is technically values. So we have a key called name, and the value is example deploy. So there are different data types which we'll go through in this video for YAML. If you look at this, I mentioned this is keys and values. The values can be of different data types. For example, this example deploy is basically a string. Generally with strings we would quote it. This is generally the best format I would always recommend, is to quote things with double quotes. But in YAML you can use double quotes, or you can even use single quotes or no quotes at all. When a system reads this YAML, it will know to interpret it as a string. So to look at more examples, if we go back to our deployment.yaml file, you can see all of these fields are basically strings. We have name under metadata, which is example deploy. We've got app as example app. We've got test equals test. All of these are basically strings. The next type of data is a number. So if you take a look at our deployment YAML file, we have this field called replicas equals 2. And then we've got a few more. Here's max search equals 1, max unavailable equals 0. YAML will automatically pick up these as numbers, and it recognizes these as unquoted numerals or integers because they're not quoted. For example, we don't have quotes around this 2. If I did this, this actually now becomes a string instead of a number. So it's good to always make sure numbers are not quoted, otherwise they become strings. They're seen as a string. Now before we go into more data types, we talk about keys and values. When writing XML, JSON or YAML, we are always technically building up objects. And objects can have a number of properties on it. An object can actually be anything. You can use your imagination to describe any type of data that you want. For example, if you're building up a system where you're selling cars, you might have to build up a cars object. And a car can have a number of properties, like a make, a model, a year, the year it was made, the type of vehicle, SUV, the fuel type, is it diesel or petrol? All of these fields become key value pairs. They become properties on our car's object. The difference between JSON, XML, and YAML is how you define that object. We looked at XML earlier where you had to define the object as tags. So you would have a car tag as an opener, and then a car tag as a closing tag, and then you would have tags inside for each of the properties, which takes up a lot more space, a lot of brackets. In JSON, these are no longer needed, and we use curly brackets to build up our object. Now in YAML, it's purely done through indentation and white space. And I'll show you this as an example. If we create a new file over here, and let's say we want to build a cars object, in JSON we would open close bracket like this. And then we would say our car has a make. So we define our key with quotes. And then the value is, let's say, a Ford. And then we use a comma to indicate that we want to create a new property. And we'll say model is Mustang. And then we might say year is 1969. And generally with JSON, once we're done with the object, we don't put a comma. If we do a comma like this, that'll be invalid because we need to define another field. So let's just keep this simple as this for now. But you can see that with JSON, you build an object using opening and closing brackets and key value pairs, and all of the keys and values have to technically be quoted if they're strings, except for this number over here, but you get my drift. So this is basically a JSON file. With the YAML version of this, what we'll do is we first open up our YAML object, and we have to make sure we close it. And then we say make Ford, model Mustang, and year 1969. So this here is technically our cars object in YAML format. And you can see there are no quotes needed, although we can quote it like this if we wanted to. YAML still supports that. It's also important to know that in XML, JSON, and YAML, we can always have nested objects as well. And this is where JSON and XML become a little bit harder to read. For example, in this car object, if I wanted to create another object inside there for, let's say, something like seat covers, right? We could create an object called seat covers under the car and then specify what type of seat covers this car has. So material is leather, it's got black seat covers, and there are 2 with this car because this car may be a 2-seater. So this seat covers, you can see it has no value on this right hand side. So if you look at this at first glance when you're new to YAML, it might be confusing because you're looking at seat covers and you're not seeing anything. However, this is where YAML uses indentation. So you can see I have 2 spaces here, which in my editor is seen as a indentation. Some people use 4 spaces, some people use tab characters to do so. This totally depends on your editor that you're using and how you configured it. But you can see YAML uses indentation here. So anything indented with 1 depth becomes part of the seat covers object. So you can see how this becomes really easy to read. If I had to do the same thing in JSON, it would look like this. So you would have seat covers, then you would define a new object with the opening and closing bracket with the key values inside there. This is still pretty easy to read for developers and engineers because we're very used to it. But the beauty about this YAML format is that it's just easier on the eye. And you can use YAML format for people who are not developers as well. For example, if you have a company which running marketing deals, you could have those deal data as JSON files and teach them how to adjust their deals and add new deals. And you can run that through a YAML validator, through a normal CI/CD pipeline type of process. And it's easy for non-technical people to manage. If I wanted to put another object underneath here, I would just indent it further. So for example, if the material here was not a string and I wanted to make this another object, I could remove this and indent it and then create like another field. Basically, I can say type is leather, and maybe I can move this field down here and put that on the material object like so. Now my material is actually a separate object inside of seat covers. So you get the idea that indentation defines where the properties belong to on that object. Everything at the root is part of the root object. So all of this is part of the car object. Then everything indented, material and quantity, everything over there is part of the seat cover object. And then type and color is indented again, part of the material object. So basically indentation and white space is what's used to build up objects in YAML. Now one thing to note about YAML is that you want to generally indent with spaces. So here I've used 2 spaces to indent and 2 spaces to indent instead of tab characters. The tab characters are generally forbidden because different tools will treat tabs very differently, so it might cause an unexpected outcome when parsing that YAML. So always good to use spaces in this case. Another piece of syntax that can be really useful is writing a comment. So for example, if I do this, I can write a comment to describe what this object is all about. You basically use the hash character, and I would always generally put a space. You don't have to, you can do it like that, but I generally put a space just to make it more neater on the eye, because everything has spaces over here. You can see that. So having a space after your hash just makes it very easy on the eye, and you can basically type anything over here. So this is what's called a comment. That's one benefit with YAML, is not only is it easy to read for humans, you can also write comments to describe the content. Comments don't exist by default in JSON. So now you probably get the idea why YAML can be really useful in Kubernetes, because when we want to describe and tell Kubernetes what we wanted to deploy, you can see we can craft an object and then tell Kubernetes this is the object that we want you to deploy. And when we learn about Kubernetes deployments and pods, services, config maps, and all the type of objects that we saw in our kubectl video, those objects are all YAML objects. So we just have to learn what those objects look like, and then we can use YAML format to describe them and deploy them to Kubernetes. One very useful thing that I like about YAML is you can also nest any type of object or just random data within an object. It doesn't have to be another YAML object. So for example, in our YAML, everything we see here are YAML objects. So we have a material object, we have a seat cover object, and then the overall car object. We can put random string data inside of this object as well without defining another JSON object basically, or another value. Let's take a look at what I mean by that. Let's say we have trunk. Let's say we have a trunk in this car. People can generally put random garbage in their trunk, right? So if I go into here, I can say trunk, and then I can do this character, and look at that, I can just put all of the stuff into the trunk. Be aware that we still have to have indentation here. So it has to be indented. I'm indenting with 2 spaces. So all of the stuff that I have in here is part of the trunk object or the trunk field. Now this is basically what's called a string block. I'm telling YAML here that I want to store a multi-line string inside of this object. So this is still a string just like we have here. Basically the same thing. It's just here I want to do a block of text. So instead of having like simple text like type is leather, color is black, I might want to create a bit of a summary. You could have another object with like car reviews and people can write reviews. Now the difference between this and a regular string is that this is just formatted like this for us to read. We basically look at this as a text block. It's nice and easy for us to read, but once a system parses this using a YAML library, it will end up being a one-line string. So when YAML looks at this, it's basically going to end up looking similar to something like this. It's going to end up looking like this. But if I had it like this, it's much harder for us as humans to read. So this is difficult for people to make changes because it's one long line of string. So by using this bracket character, I can tell YAML that I'm going to be writing this as a string block, multi-line, but I don't care how you format it. So when it reads this, it will read it as a single line. This is useful if you just want people to write content like this, but you don't care how it's being stored somewhere. If you're writing this to a database, it can go in a single line. But what is more useful is if you want to preserve these line breaks. If you actually want the data to be on separate lines, you can use the pipe character. So by using the pipe character, when a system reads this, it'll keep the line breaks in this format. So it will read it exactly as we see it here now. Now, why is this useful? It can be useful for people to edit text blocks like this and then store it exactly like this. But in Kubernetes, it's very useful if we take a look at configuration data. Once we look at pods and deployments, we'll want to deploy some applications, microservices or something to Kubernetes. Those microservices or applications may have config files. If you're familiar with any type of programming language, generally when you build a system, you have a config file, like a JSON file or an XML type file, and your application reads that when it starts up. It allows you now in YAML to write a config file and embed it inside of an object. So if this was an application, we could say trunk.config, and Kubernetes may look at this as a config file and it will place a trunk.config inside of our pod with the details over here. And that means this .config file can be any type of format. It can be an XML type format, something like this. It can be JSON, it can be nested YAML, it can be pretty much anything we want. This is just a pure text block. So it's a very useful capability to understand within YAML. Something that's really cool with YAML that other data structures don't really have is the ability to just nest random data inside of our document. This becomes really hard to do in JSON because if you had another document you want to embed, like a config file that you want to embed in a JSON document, and you have quote characters and some of the characters might be used by JSON, that becomes really hard for an interpreter to interpret. Now, another type of data object or data type in YAML is arrays. Now, an array in YAML is basically just a list of objects. So far, we've taken a look at nested objects. So we have a material object, part of our seat cover object. The seat cover object is part of our car object. But we could have a property on our object, on any object for that matter, that has a list of items. This is quite useful in YAML, especially in Kubernetes. When we start to take a look at things like pods, a pod can have multiple containers running as part of that pod. Generally in microservices, we generally just have one container running in the pod, but sometimes you might have another container running inside of that pod. When we define multiple containers, we define them as an array, or a list of containers. Now, arrays can be defined anywhere. Just like we have types of strings, types of numbers, we can have an array. So for example, at the roots of this object, I can create another key called previous owners, and in here I can create an array. So we define an array by these like dash characters like this. So if I want 3 items in an array, I would have 3 items like this. And then I can start just by building a new object. So I can have name equals John. Let's say his age. I can have all his properties on here. I can then say owned from, and then owned until. So we can track and say this owner has owned it from this date to this date, and then we might have another owner, and we can have another owner. So basically in YAML, the dash character indicates that this previous owner's data type is a type array, and the dash character starts a new object. So we always have to say dash and then space and then specify the key value and start creating another object. And you can see we use indentation once again. We can actually expand this by adding more data types as well. If we wanted to create another object underneath this one, we could do that as well. So we can build complex objects using YAML. So in this example, my array is basically an array of objects, but we could have an array of strings if we just wanted to. So for example, I could wipe off all of this. I could wipe off these fields like so. This is still an object, so we still have 3 objects here, but I could just have an array of strings like this if I wanted to simplify it. So we can have an array of strings, we can have an array of numbers, we can have an array of pretty much any type of data. So that's arrays in YAML. Another type of data type in YAML is a Boolean. Booleans can be fields that have like a true, false, or a yes, no, or an on or off, or a type of switch. So for example, if we take a look at our YAML, if I wanted to introduce a new field here to say is used, we can say is used is true. This can be a true or false, yes, no, on, off, basically a type of switch value. Now, it's important to know that Boolean in YAML is case insensitive. So I could have true like that. I could have it spelled with capital T, RU. I could have all lowercase. I could have it on with capitals. I could have yes capitals. I could have yes like this or yes lowercase. This is kind of the beauty of YAML, is that it's very user friendly. So there's a number of keywords we can use to indicate true or false. That is yes, no, true, false, on and off. Now that is the basic fundamentals and all you need to know to work with YAML with Kubernetes. Now, if you're new to Kubernetes and you're new to YAML, I would highly recommend to use an IDE or a special editor that developers and engineers use to do DevOps and engineering work. A very popular IDE is Visual Studio Code. Now you probably have Visual Studio Code already, but if you don't, go ahead and download it. You can see everything we've done so far. We've been using Visual Studio Code. It's a rich text editor that allows us to format and view things in a pretty way. It comes with a lot of integration to Git. It has a file explorer where we can explore directories and our Git repos, and a lot of extensions and plugins. And the cool thing about VS Code, if I click View and I click on Terminal, it has a built-in terminal where I can start running kubectl commands. So I can use this as an editor for my YAML and work with my Kubernetes cluster. There are a lot of other editors out there, but VS Code is by far one of the most popular ones. And if you don't have it, you can simply go to code.visualstudio.com and just hit the download button. Visual Studio Code is free and supported for Windows, Linux, and Mac OS. So now that we know the fundamental basic structure and syntax of YAML files, what I can do is quickly run through a couple of Kubernetes examples before we take a look at those objects in depth in future videos, just so you can see how the syntax that we've just learned relates to Kubernetes YAML. And the purpose of this video is for you to understand the fundamental basics of YAML and the YAML syntax. So you want to make sure that when you're writing YAML, you're not introducing syntax errors. And if you're using Visual Studio Code, it'll highlight when you're making syntax errors. So it's very useful to use something like VS Code when working with YAML, as it will tell you if you're breaking the YAML syntax and you're doing something that's invalid. This can happen when your indentation is incorrect, especially when you're copying YAML. So let's say you go to the Kubernetes website and you want to create a deployment or a pod, or you want to copy some environment variables to copy it to your container in your YAML file. A lot of people do this. They go to the internet, they find some snippet that they want, and they paste it into their YAML file. And because they paste it, they break the indentation sometimes. Sometimes you have to make sure your indentation and your white space is correct after hitting the paste key, because if your indentation is off, you can break the YAML syntax. Generally, when you're using kubectl and you're passing YAML to Kubernetes, it'll tell you when there are syntax errors, but it's very important to understand the difference between YAML syntax errors and Kubernetes errors. For example, when we break the syntax of YAML, like we don't have the semicolon, or we have bad indentation or bad white space, then we'll get a YAML error. However, even if our YAML is correctly structured and there's no syntax errors, we might get an error from Kubernetes. And this can happen because some of the fields that we have in YAML might be incorrect. So when we look at pods, deployments, secrets, services, config maps, and all the Kubernetes objects, we'll learn about the right fields that we need to use. For example, as I mentioned before, a pod can have an array of containers. A deployment can have a field for replicas. There are certain fields that deployments support and certain fields that pods support. And all of these different objects in Kubernetes have different fields, and we want to make sure we understand those. In future videos, we'll go through those objects in detail. So going through a Kubernetes deployment as an example, you can see we have a bunch of key and value pairs. So here we have a key called API version. Every single object in Kubernetes has a version. And then we have a kind. This tells Kubernetes what type of object we're looking at. This can be a deployment, a pod, a cron job, a service, a config map, a secret, an ingress. All of the different types of objects that Kubernetes supports goes under kind. And then generally we start with metadata. So you have metadata, and you can see, as we learned earlier, that this is actually an object. There's no string or anything on the other side, and it has indentation. So this is the metadata object over here. Everything that has two spaces is part of the metadata object. So we have a metadata object here. It has a name, it has labels. This labels is also an object of key values, because we can see there's more indentation here. So we have a nested object. We've got an object here called labels, which sits on the metadata object. And then we have an annotations object, which is also part of the metadata object because it's indented by two spaces. And the annotations have a bunch of keys and values. And then the same kind of logic applies to all of these other fields. Now, if you're using VS Code, you can actually collapse these and see which objects they're part of. For example, if we take a closer look to this deployment file, I can collapse this metadata object and I can collapse the spec object. You can see these are all comments, as we learned about earlier, so we can go ahead and ignore this. But basically we have a root object, which is this whole thing over here, with two sub objects, metadata and spec. If we expand the spec, we can then break it up further like this. We can expand them and collapse them. So now it allows us to visualize to see how many objects are under spec. So this is just a little run through of the indentation and white spaces and how objects are structured in YAML and how that applies to Kubernetes. So this whole thing is a deployment object, and you can see here's an example of an integer or a number. So replicas 2. We basically tell Kubernetes we want 2 pods as part of this deployment. Now if we expand this template further, we can see we have nested objects again here, and here is an example of an array. You can see I can use this little arrow here to drop down the array. You can see there's only one object in this array. This is an array that's part of a field called containers. So containers is the name of the field, it's the key, and the values is a list of containers as an array. So this only has one array item, and its name is example app. And it's actually an object, so it's another object that we have going here. We can have nested arrays, so in this case this whole thing here is a container, but this container has another field called ports, which also has an array. You can see over here I have another array for ports. And you can have multiple ports as part of it. So I can say container port, and I can actually create another port and expose another port on here, as this is an array of items. So that gives you an example of a real life usage of an array. Another example, if we take a look at our Docker development YouTube series, we take a look at the Kubernetes folder, and inside there we have a services folder, and inside there we have a service.yaml. This is a much simpler YAML, but you can see the same thing here. It starts with API version and kind as a service, and then we have a basic object structure like this, and there's an array over here. There's an example of strings, so all of these are string fields, and an example of an array as well. So this whole thing is a port object, and there's an example of an integer usage as well. And then an example of nesting data within YAML, like nesting configuration files. We can take a look under the Kubernetes folder. There's a ConfigMaps folder with a ConfigMap.yaml, and here again we have string fields, so API version and kind. And then we're using this pipe character here to specify data of this config file. So we tell YAML that there is a field called config.json, and its content is just this text block. So this is an example similar to what we looked at earlier with our car object, where we specify just random text block data to be embedded within a YAML object or a YAML key. The key in this case is config.json. Now in the context of Kubernetes, with YAML doesn't know what this means, but for Kubernetes will take this as a config map. It's a special configuration type of object within Kubernetes that allows us to deploy configurations for applications. Think of like if you have an Apache web server or an Nginx web server, you might deploy an Nginx config or an Apache config, like an htaccess type of file, and store that as a configuration and embed that in here. And YAML allows us to do so. And Kubernetes supports that as well with the config map. So that's about as complex as it gets with YAML and Kubernetes. So hopefully this video gave you a gentle but effective introduction to YAML with Kubernetes. How to write YAML and structure the syntax, how to understand the syntax, the indentation, different types of objects, and how all of this will apply to Kubernetes as we move forward. Now I'd like to let you guys know that I'm also working on the Ultimate DevOps course. This might be something that I've mentioned in previous videos, but check out the link down below to the social so you can follow along with the development of the Ultimate DevOps course. It's basically a roadmap style course for new engineers that want to get involved in DevOps and don't know where to start. It'll take you on a journey from the beginning, looking at things like Git, IDEs, source control, then taking a look at virtualization and servers, creating our first server using virtualization technology, creating our first little website, learning about web servers, HTTP, Linux, how to manage operating systems, how to create a web server, how to learn all the fundamentals of web. And the roadmap goes on. It's a course with roughly 10 chapters that I'll be publishing under early access mode. And there'll be a lot of free videos on YouTube covering this as well. Check out the link down below to the DevOps course. And I'll also have a channel on the Discord for early access feedback. So check out the link down below for the community page so you can follow along with the development of this course and have an early access glimpse of what's to come. And in the next video, we'll take a look at pods. So if this video helped you, be sure to like and subscribe, hit the bell, and if you want to support the channel even further, check out the link down below to become a YouTube member. And as always, thanks for watching, and until next time, peace.